All right, welcome back, Precalcsters. In this video, I am still out to help out with some testing stuff, but jumping in, I want to remind us that in our last class, we started looking at these things called vectors, which are just these fancy arrows that go a certain distance, called the magnitude, in a certain direction, which we can use theta or we could use slope, and then just a few little things notation-wise. Remember, we use this little half arrow right here to indicate we're talking about a vector with initial point A and terminal point B, or we use a lowercase letter all the same, and these fancy double lines for magnitude. All right, so last class, all we did was we looked at, hey, here's two vectors, let's see if they are the same for all intent and purpose, and we saw that, yeah, they are equivalent, same length and same direction. Cool. And that led us to this idea that things are always easiest if we start at the origin, which is what we call a vector in standard position. So we are going to look at component form of a vector, and we're going to define this fairly specific. So if your notes and things aren't out, please ask somebody to pause this. Let's get ready to roll, because I'm going to start in with this definition in 3, 2, 1. All right. So right off the bat, as we're looking at these things, we know that the component form or the standard form is easier, and the components are just the horizontal piece and the vertical piece that make a diagonal line. So here we go. If we have a vector, let's say we have a vector has initial point, and we're just going to say that this point is P, and purely this can be anywhere. We're going to call it P1 comma P2, so it's some coordinates. Cool. And terminal point, and the terminal point at Q, which we'll just say that by definition that's Q1 and Q2. So any 2 points, and we just keep it straight by P and Q. All right. Then if we get this, the vector, the component form of this vector is, and I'm going to give you guys just a second, and I'm not going to write this all down, but if we have a vector and we have an initial point and a final point, then the component form of this is, and I want to think about this. So you do not need to sketch this. You can if you want, but we're going to be able to make sense of this. Let's say that I'm in quadrant 1, and here's point P, P1, P2, and we run all the way over here to point Q, which is at Q1 and Q2. All right. If we have this vector, and I want to know the components, all I'm really worried about is from here to here, how far over did it go? And it turns out that that is crazy easy to find. We use a little tiny different notation here, but let's look at that. If I wanted to find the component form of PQ, it is as simple as just giving me how far horizontally and how far vertically does my vector need to move. Now, we use these fancy Instagram peace sign brackets when we're looking at component form to specify that this is what it is. And if I want to know how far horizontally have I gone, turns out super easy. It is just Q1 minus P1, which is terminal initial point minus initial in the X. And then we'll just do the same thing with the Y's. We'll call it Q2 minus P2. And we'll close it with these lovely brackets. Now, from time to time, because writing a vector with 2 points can be kind of cumbersome, what's pretty common to do is to call this vector V. That's standard to start with. So if we have a vector V that has some x coordinate, which we'll just call V1, and I'm going to change this to V, then we'll just say that the y coordinate, whatever we get by the difference here, is just V2. Okay, this is how we write this vector V. And I'm going to do one little thing. If we say PQ is this, then now it seems more natural maybe to change this to vector V. Okay, all we're doing is we're taking this, and instead of saying start at P and go to Q, it's like we're just taking this whole thing up, and we're just going to slide this whole vector, and I'm going to physically slide this here for us, hopefully. We are taking this whole vector right here, and it's going to copy some of the other one. That's okay. We're taking this vector, and instead we're just moving it down here so that it starts at the origin, which is super convenient. So I'm going to make that note here in just a moment. We get this new vector that we call v in its standard form, where v, this new vector that we've just created, it's equivalent. The only thing is different is where it starts. So v is in standard form, and I'm going to use stnd, which just means starts at the origin. And furthermore, if we want to talk about the length of it, now it's even easier to find. If we find the magnitude of this guy, all we have to do is just think about the Pythagorean theorem. So if this is v1 and v2, then the magnitude is just the square root of the hypotenuse, or in this case, pq is the actual vector, and it's just v1, we'll square it, plus v2 and square it. So take the x-coordinate squared plus the y-coordinate squared, and then take the square root. And we have a lovely vector in component form that starts at the origin, and we know its magnitude. All right. Now, as we look at these things, they are super nice to deal with, and there's a couple more little tiny pieces that I want to make sure that we have definition-wise. If it turns out that the magnitude is a 1, so if the length of my vector, the magnitude, is equal to 1, then we have what is known as a unit vector. Then v is a unit vector. And this language hopefully sounds okay, because just like our unit circle, it just means that we have length of 1. Okay, unit vector is just a vector with a length of 1 unit. Okay, other little piece, and this one feels silly, but if by chance the magnitude of this thing comes out to be 0, so there was no distance traveled, no length, then we have the identity vector. And I'm sorry I'm pausing here just a little tiny bit. I want to make sure that my language is correct. And I'm just going to say then v is the 0 vector. Okay. Now we'll talk about the identity and stuff in class as well. Typically, the way that we write the 0 vector is just a 0 with that vector symbol above it. All right. So one last little piece, and today's lesson is going to be fairly short, it would seem. All right. So as we kick forward, we're going to do one quick example where, here we go, I want us to find component form. All right, so here we go. On A, we have a lovely vector v that starts at -3, 2, so that's our initial point. Starts at -3, 2, and ends at, let's say it's the lovely point 8, 2. All right. So there they are. When we look at this, nothing crazy about it. We'll just switch gears here. I know that this is what I'm looking at as my initial. So this is like my P1, P2. And this would be my terminal, or in our notation, Q1 and Q2, which means this problem, super straightforward, I hope. This vector v, turns out we get these lovely Instagram brackets, and we're just going to take the difference of the x's. So I see it's Q1 minus P1, which is 8 minus -3, and Q2 minus V2 is 2 minus 2, We'll close those lovely brackets. And it looks like we wind up with the vector 11, because minus a negative, 0. Now, this vector is the exact same in length and direction as my original, except it starts at the origin. And it means it's really easy to graph these things. I'm not asking you to graph it in this situation, but if we wanted to graph it, instead of my initial vector being down, let's see, negative 3, 2 is like over here, and it ends up over here. Instead of it being this vector, we're going to pick up that whole vector that starts here, and we're just going to move it to right here, which is so much more convenient. Now, when we start doing addition and things like that, this will play a more pivotal role, but wasn't required or asked, but it's worth doing it here. If we want to find the magnitude, now that we have this, it's super easy. It's the square root of this first term, 11 squared, plus the second term, 0 squared. And it's obvious when we look at the picture, because it's just a horizontal line, but this thing is going to wind up having a magnitude of 11 units. And I'll make sure that those look like ones here. All right. Now, super short video today. What I want you guys to do is spend a bit of time working through homework 6.3.1, which you will find waiting for you on page 427. And I want you to do problems 1 through 7 and 11 through 23 odd. If you happen to finish early, please find something to look at. I'm never going to be offended if you wanted to go a step further and start looking at vector operations in your text, but that is certainly not required. Cool. All right, super short, super chill. You guys have a wonderful day, and I hope that you never had to watch this video because I was back, but we'll see. All right, good luck on the homework. Later, Raiders.